So in this case, we are going to consider our introduction to the Kirchhoff's laws, as we do understand that our Kirchhoff's laws, actually, there is nothing that is going to actually change from what we had previously, considering our N1, N2, N3. The part of the Kirchhoff's laws is still the same. Remember, we consider the two laws in our syllabus, or in the simplification. Actually, there are just two laws that you are going to work with. And these laws, they are referred to as, number one, we are going to apply the Kirchhoff's current law. So the Kirchhoff's current law, it states, or it is about the current, given that the current is flowing towards a certain junction, and there are actually many or different currents that are flowing towards, and some of these currents, they are flowing away of the junction. Let us consider this typical path that we are given. So you're going to have this current flowing away, and also maybe this one flowing away of the junction. The relationship is going to be the algebraic sum of all currents entering the junction. So we're going to have the currents entering, these ones flowing towards, the algebraic sum of these currents entering the junction. It must be equal to the algebraic sum of these currents out of the junction, going out, leaving the same junction. So it's the currents entering, the currents leaving. So these are the currents that are entering the junction, and these are the currents that are leaving the junction. Or we can simply say this algebraic sum of everything that we have must be equal to 0. So if you are to notice this, you're going to have these two minus this must be equal to 0. But from this concept, we are saying I1 plus I2 must be equal to these ones flowing away of the junction, which is I3 and I4. What if we were to take these values this side? What was going to happen? We're going to carry a negative, meaning to say we're going to end up with I1 plus I2. We take I3 and I4 to the left-hand side. So that's going to be minus I3 minus I4 is equal to 0. So we can say the sum of currents entering and leaving the junction must be equal to 0. The sum of currents entering and leaving. So those ones entering, you present them with a positive. Leaving, you present them with a negative. That's the idea there. All right, number 2 is on the voltage. So we are going to consider our Kirchhoff's voltage law. How can we consider this? It is going to be taken in a closed loop. Considering a closed loop, let's say we have got, in this case, these resistors that are in a closed loop, and we've got the total voltage, and this is our R1 and this is our R2. The current is flowing. So in this case, we do understand from our simplification, this is the movement of the current from the positive. We're going to have the current in this direction. But we are also going to notice sometimes you might be given this flowing in this direction. You have to consider the question, how it is given. But in this case, I'm going to present in the normal way that we are used to. So that is our current in that case. So in this closed loop, the sum of the voltage drops that we are going to have, there will be a voltage drop must be equal to the EMF, the sum of the EMF that you'll be given. Maybe there are 2, there are 3, you combine them. So the total, the sum of these voltages must be equal to the sum of the voltage drop. And what is the voltage drop? Current times resistance, current times resistance. So it is the sum of current times resistance. So with this, we can formulate equations that can be used to solve unknown currents. Or we can simply take this to the other side. That means the sum of the voltage must be equal to 0. Everything that we have must give us a 0. Sum of all voltages around a closed path is 0. So let's consider this question. We do not have a source. We do not have a voltage. This is from the hands-on. So we do not have a voltage source. We're just given the currents determined by calculation with the aid of the Kirchhoff's laws, the magnitude of current 1, current 2, and I1 minus I2. So in the simplification, because these textbooks, they present differently, but in this case, there's nothing that is different. You are going to notice in terms of the currents, use the way that you are given on that diagram so that you do not fall into any temptation of answering wrongly your questions. Follow the way that you're given. So in this case, we are already given the loop 1 and the loop 2 with the direction of the currents already presented. I1, and this is I1 minus I2, since I2 is taken this way. So considering this loop, we are going to take, all right, so let us have the first loop. As we can see, we need current 1, current 2, and also I1 minus I2. So if we are to consider the first loop, which is loop 1, I'm going to take it from A, B, D back to A. So this is A, B, D, A. In this loop, we do not have a voltage source. If there was a voltage source, we are going to apply that, but the formula is not going to change. The sum of the voltage, the sum of these voltages that you are going to have, but in this case, there's nothing. There's nothing that we are considering as the source voltage, but it must be equal to the sum of the voltage drops, meaning to say current times resistance. There is current, resistance, so we can use that. All right, so let's consider what is happening from point A to point B. From point A to point B. The current is moving in the, look, the loop. The loop here is going this way. So you consider how the loop is going. So if you consider the current and the loop are in the same direction, so that's a positive that you have to consider there. But do we have the voltage? No. So that 0 is equal to the voltage drop. Current times resistance. So that's 10 times I1, and that's a positive. We move on from B, from this point B to D. B to D. There is a current that is there. And this current is in the same direction as the way that we are moving in this loop. A, B, look guys, A, B, D, A. So from A to B, we are moving the same direction. From B to D. From B to D, we are moving. The current is going the same direction. If it was like this, look, if it was going like this, it was going to be a negative because it's opposing how you are moving in the loop. B to D is moving the same way. So it's going to be a positive. So that's 20 times the current. So 20 times our current there is given as I1 minus I2. That is, we are at point D. Then from D to A, we are now going back from D to A. What is happening from D to A? There is a current, but look at the movement now. We are moving this way, D to A. This is the way that we are moving. But look how the current is moving. It is opposing. The current is going this way. It is going from A to D. The current, as we are moving from D to A, but the current, the way it's presented there, is moving A to D. Once it is like this, you indicate it with a negative. It is opposing the movement that we are having on our loop. So that will be minus 30 into the current, which is 3 minus I1. We are already given there the current, which is 3 minus I1. So that's it. We have formed an equation considering the way the loop that was presented. So you can simplify further. That 0 is equal to 10 I1. So you're going to have 10 I1 plus 20 times I1, which is 20. I1 minus 20. I2, you multiply by 20 this side. Minus 30 multiplies the 3. So that will be negative 90. Minus 30 and minus 1. That is going to be positive 30 I1. So as we can see, negative 90, we can transpose this to the other side of the equation. so that it is going to be a positive 90 there is equal to, working with the current one, there is I1 here, there is I1, there is also I1, so we can consider collecting of the like terms in that case. So you consider this part, we have got I1 here, we also have I1 here, you add, there is also I1 here, you add. So adding these was going to give us 60 I1, all right? So this is 60 I1, we are just left with minus 20 I2. So this is our first equation, of which you can just write starting with the unknown values there, 60 I1 minus 20 I2 is equal to 90. So that is our first equation. You can reduce your equation if you want, or just leave it like that. If you do not want any confusion, just leave it like that. You used this loop number 1. All right, so for the sake of using our diagram here, where it is, I'm just going to remove this and have our equation so that it does not affect us to moving this and that. So we saw that equation 1, we obtained 60 I1 minus 20 I2, which is equal to 90. All right, so this is our equation 1. Let's formulate equation 2. Using which loop? So we are going to consider the second loop according to the way that you are given this way. It is supposed to move in this way, So you can start from C to D to B, back to C. You can start from B to, as long you are moving this way, as long you are taking the way that I'm indicating in a clockwise, the way that is presented. So as for me, I'm just going to start from B to C to D, back to B. I'm moving in the same direction. So that is loop 2. I'm going to take it from B to C, then from C to D, then from D back to B. All right. So considering this loop, are we having the voltage? We do not have. So as you saw, the sum of the voltage drop, guys, the sum of the supply must be equal to sum of the voltage drop. We do not have the supply. So this is equal to a 0. That's a 0 is equal to, we need now the voltage drop, current times what? Resistance. So let's move from B to C. We are moving from B to C. From B to C, look the way that we are moving. This is from B to C. Is it the same way current is presented? Yes, it is the same way. Going from B to C, this is the way that we are moving, and the current is moving in the same direction. So when it is like that, it's just going to be a positive. So that's 20 times I2. All right, let's move on from C to D. From C to D, this is the way that we are moving. From C to D, we are moving this way. Is it the same way the current is moving? No, the current is opposing. The current is going up. As we are moving C to D, the current is moving D to C. Whenever it opposes like that, I said you indicate with a negative. So that is going to be a negative 24 times the current. Our current there is 3 minus I2. All right, let's move on. We are now at D, so you have to go back to the point B, D to B. So from D to B, we are going this way. This is the way that we are moving from D to B. Is it the same way current is moving? No, the current is moving from B to D. It is opposing. So that's a negative again. So we have got a negative here. We are going to also have a negative there. So this is negative what? What is the resistance here? The resistance is 20 ohms. So that's 20 times the current, which is I1 minus I2. Having what? A negative. So that's 20 into I1 minus I2, just like that. So you must consider the presentation of your diagram in that loop, in the loop that you are working with. We are going up, but the current is going down. We are going this way, the current is going the opposite way. You put a negative in those situations. So that's 0 is equal to 20. I2 minus 24 times 3 was going to give us minus 72. Minus 24 times minus I1, that's a positive. So that's 24. I2 minus 20 times I1, that's minus 20 I1. Minus 20 times minus, that's a positive there. So it's going to be positive I2. So you're just going to Take this negative 70 to the other side, it becomes a positive. So that's 72 is equal to, let's consider our like terms in that case. Current one, we just have this here, only this part where we have got current one. The remaining is current 2. As we can see, this part here is current 2. This part here is current 2. You have to add current 2. This also is part of current 2. So that is in terms of the current one, we are just going to have minus 20 I1. So that's minus 20 I1. In terms of current 2, you add 20 plus 24 plus this 20, which was going to give us 64 I2. So that's our equation, guys. So we can just write up our equation 2. So we've got determined our equation 2 from this loop. So that's our equation 2. It's going to be this part, minus 20 I1 plus 64 I2, which is equal to what? 72. So that's our equation 2. So with these equations, you must solve them simultaneously. As we can see, I've got two unknown values to be considered. So we are going to solve these values for I1 and for I2 simultaneously, depending with the method that you are best at. Is it elimination? Is it by substitution? So in this case, I'm going to use elimination, take rid or get rid of I1. If I want to eliminate I1, it means I have to remove I1. I just have to make sure that the coefficients, these two numbers, must be the same. So in actual sense, you were supposed to multiply on top by 20. Below, you're going to multiply by 60. But look, guys, these numbers can be reduced. 20 into 20, that's a 1. 20 into 60, that's a 3. So instead of using you using the 20 there and the third and this 60, no, just use 1 and 3. I'm not saying to use 20 and 60 is wrong. No, I'm not saying that, but you can reduce. So what I'm simply saying, let's say you are having a 10 and you're also having a 5. You reduce 5 into 5 is 1. 5 into 10 is 2. Let's say you're having a 30 and a 20, you can reduce 10 into 10, that's 10 into this 20, that's a 2. Into this, that's a 3. So instead of you using 30 and 20, you use 3 and 2. Instead of using 10 and 5, you use 2 and 1. You can reduce the values that you have indicated there. So in this case, we were supposed to have multiplied the whole equation on top by 20. This whole equation by 60. But this can be reduced. 20 to 20, that's a 1. 20 to 60, that's a 3. So reduce your values. That's what I'm trying to say. So in this case, we are going to multiply the whole of this equation and the second equation. We multiply on top, like I said, by 1. Here we are going to multiply by 3. Instead of 20 and 60, you reduce the values as they are. You just reduce those values. So these values, they are not going to change. We are going to have the same part here. Okay, let's multiply and see. 1, remember it multiplies everything on top. So that's 1 times 60. It's going to be 60 I1 minus 20 I2 is equal to 90. 3 multiplies everything in the second equation. So 3 times minus 20, that's minus 60 I1. We multiply 3 times 64, which was going to give us positive 192 I2, which is equal to 3 multiplies the 72, which was going to give us 216. So as we can see, the part of I1 is the same. There's a 60, there's a 60. Even though one is negative, one is positive, all you just need is to eliminate that I1. So how can we eliminate I1? Since it's the one that we wanted there, how can we eliminate this current? Are we going to add these two or are we going to subtract? So you try on your calculator, 60 plus minus 60, it gives you a 0. But if you subtract 60 minus 60 like this, it was going to give you 120. You haven't eliminated, you still have it, because it's going to be 120 I1. But if you add, it is going to be 0 I1. Thus you have eliminated, because any number times 0 is what? It's a 0. So to eliminate these two, you are going to add these two equations. So you add 60 plus minus 60. That's a 0. So that's 0 I1. It's no longer there. Okay, you move on to the other part of our equation. Minus 20 plus 192. So it's minus 20 plus 192. So guys, a plus and a plus does not affect. It's just gonna remain as a plus. So that is that was going to give us 172. So in this case, we're going to obtain 172 I2. Okay, so remember there we are adding. So you also add this to 90 plus 216. So this was going to give us 306. Since you want to calculate I2, what can you do? You can simply divide by 172, divide by 172 both sides. This was going to give us I2. So 306 divided by 172 is 1,779 amps. Remember, this is current, and our current is measured in what? In amps. With this current too, you can simply substitute in any one of these equations to calculate current 1. You can substitute in equation 1. You can substitute in equation 2, any of your choice. So in this case, I'm just going to take equation 1 from equation 1. All right, so from equation 1, we have got 60 I1 minus 20 I2. And I2, we got the value. And what is the value? 1,779. This must be equal to 90. That is what we are given there. So we can calculate the value of I1. 60 I1, we multiply these two, you're going to obtain minus 35,53 is equal to positive 90. Take this to the other side. It's a negative, so it is going to be a positive this side, 35,53. That's determining, that's going to give us 125.53. Okay, so since we want the value of I1, just divide by 60 both sides. That will give us the value of I1, which was going to be 2,093 amps. So we have got current 1 and current 2. But the question was, we are supposed to determine also I1 minus I2, which is this part that we had in the middle of our circuit diagram. Remember here, that's where we have I1 minus I2. So we also need the value of I1 minus I2. So from this, what was going to be the value of I1 minus I2? Already, we have I1 and I2. So meaning to say I1 minus I2 is the difference. I1 is 2,093 minus I2, which is 1,779. So that is the difference there was going to give us I1 minus I2, which was going to be 0,314 amps. So that is our I1 minus I2. You have to determine each and every part that you are given there. So questions can differ depending with what you have thereafter, after finding, because you now have the currents. So they can even ask you to calculate the voltage drop across this resistor, where there is I1 minus I2. We can calculate that. Remember, voltage, current times resistance, but we are using this I1 minus I2. They can ask you to calculate power. V squared over R power, it's I squared times resistance. Power is voltage times current. Depending with the part that you're given, they can ask you those values. It's not just about currents. It can be power, it can be anything. So we shall see typical questions as we move on. But as we are to consider our Kirchhoff's laws, you need to formulate equations in a given network that you have using the voltage drops. The sum of the voltage drops must be equal to the supply voltage that you'll be given there. Then you form equations, solve those equations in a way that you understand. Is it by elimination? Is it by substitution? Even determinants, if you understand, remember those mathematical calculations that you have in your mathematics N4 on calculating or on solving simultaneous equations. Any of those methods can be used. All right, so this is what we had. Till we meet again.